Test, test, test. Okay, that looks good. See if anyone's in yet. Okay, we have a couple people that are joining in. Just was up and about. Oh, I should get some water. Okay, I'll be right back after water. Alright, now I have everything I need to get settled in and start playing this game. Alright. Been a little over a week, I think, at this point. I was intending to play this on Friday, and then I didn't. And I was also intending to play this yesterday, and then I didn't. And then I was also intending to play this on Thursday, and then I didn't. But I'm here now, and I'm ready to start it up, so that's good, right? That's gotta be worth something. Couple other things of note, I guess. If you're on Twitch, I have submitted an emoji. I don't know if it's in yet. I think that they have to review the emojis to make sure that they're safe for work or something like that. I'm not entirely sure, but I assume that that will be coming in a day or two. And when it does, everybody can feel free to spam it as much as Nightbot allows them to. Alright, let's get back into it. Well, welcome back to 7 Billion Humans. We're going to Sorting Hall. I am dreading this. Oh, no. What the hell are these things? They're robots. Okay, don't be alarmed. Let's not make any sudden movements or step out of line. We're being evaluated. I need you to calmly sort the line of cubes, from smallest on the left to biggest on the right. Yes, I remember when problems like this used to be difficult when there was only one person working on it, but now we've got teamwork. Arrange the data cubes in order from smallest on the left to biggest on the right. The data cubes can stay in your workers' hands, no need to set them down again. If two workers are both trying to walk on the other one's tile, they will swap positions. Okay, cool. So, I now get to implement a sorting algorithm. That's nice. Alright. There's a lot of ones to choose from, and some of them work a lot faster than others, but what we're gonna do to begin with is we're just going to bubble sort this thing. So everyone's going to compare. So we have two edge cases here. We have the left and the right. So first off, everyone's just going to pick up the cube in front of them. And that'll be simple enough. And if there is a... What we'll do is we'll compare to the left. Let's see, what makes the most sense? If we compare to the left, and we find that that person is smaller, then we'll just swap positions with them. Likewise, if we compare to the right, if that person is larger, then we'll swap with them. Now, the thing is, we need to synchronize that so that both people try to exchange positions at the same time. So that'll be interesting. But for now, we'll basically look at if my item is less than the worker, less than the right, or less than the left, then we'll swap. Then just step to the left, and the other so that's one step, but then the other person will be desynchronized because they'll do their if check after this one. So what we could do is step to the left twice. So else if my item is greater than the person on the right, then step right once. And I don't think that this is going to work, but we'll find out how much of a disaster this is. And then we just simply jump back all the way to here. And I don't think this is going to work because I assume this synchronization that I've put in is probably bullshit and is not going to help at all. But we'll find out. Let's just watch. Everyone picks up the cubes, and people are slowly kind of brute forcing their way around. This might actually work. No, so this isn't going to work because 6 is not going to swap with 61. So people are just going to scurry in place for forever. All right. So this person is, for whatever reason, deciding not to step to the right. And if my item is greater than the right, then I should attempt to step to the right. So this should be sort of working, shouldn't it? Let's go real slow. So they keep checking if my item is greater than the right, which they should, because 61 is greater than... So... Oh. Oh. What am I thinking? Okay. My item is less than the left. If my item is less than the right, then I step to the right. And I think I don't actually need this extra step. Because I think that what... Okay, so I don't actually have to do a synchronization between the stepping. Because basically, they'll just keep attempting this step over and over until they make it over there. And that should... This should now work. No. Because if I'm to the left of something and I'm less than it, then I don't want to step to the left. So, how about if right is less than my item? Aha! That's what I need to do. So, I check the other direction. This should work now. So, they swapped. Alright. And this should eventually bubble everyone to where they need to go. Perfect. So that's bubble sort. And it is very slow and inefficient, and I don't know if there are better sorting algorithms, but... I mean, I know there are tons of sorting algorithms. I don't know if there's a better one that's feasible to implement in this game, but I just did it. So, what an astounding display of teamwork. Humans are definitely not obsolete. I think that I probably got the shortest program, or at least very, very close to it. And I actually did pretty fast. My average of 22 seconds. So my very, very inefficient sorting algorithm still ended up being pretty good. So I wonder then how I could have possibly have done this more efficiently. There needs to be this step, and I wonder if I don't need this else at all. So if I just take out the else branch entirely, maybe this will also work. Alright, so that's how you do it even shorter. Humans are definitely not obsolete. And let's check this out. 6. My average of 24. Boom. Perfect execution of this puzzle. Very proud of myself right now. Continue to the elevator. Alright. Budget Brigade 1. Level 24, I guess. Well, this is clearly dangerous. Facilities management was supposed to install conveyor belts in here, but we couldn't afford conveyor belts. Because someone blew our budget on shredders. So everyone just think like a conveyor belt. Print stuff on the left, shred it on the right. Let's not overthink this. Oh yeah, and for safety compliance, no one is allowed to leave their tile. Print and shred at least 50 data cubes, no walking allowed. Pro tip from management: workers can give to or take from other workers. Note that you do not need both, just one or the other will do. Now that's teamwork. So, we will take from below, and we will, I guess, well, okay, so if direction below equals shredder, take from, and then just keep give toing the right, and, or I guess we'll do another if here. So if below is equal to shredder, so if below is equal to printer, then we take from. If below is equal to shredder, then give to. And I can also make this more efficient, I think, but this should solve the problem. Okay, so 67. Oh. Oops. So these person did. So I forgot that if we have a shredder and my item is equal to a data cube, then we do the give to. Otherwise, so this is a nice little safety check to keep in mind. We should only give to shredders if we're holding a data cube, and we can always have that conditional check there. So, just give, and I forgot to loop. So now, we jump back here, and now this should solve the puzzle. I forgot to loop. That's fine. So, everyone else has nothing to give. I wonder if that action of them saying that causes the causes a slowdown, because maybe they can't speak and receive an item at the same time. In fact, it looks like that's the case, so this is going to probably be the shortest program, but it's also going to run relatively slow because a whole bunch of people are locking up they're just waiting when they could be doing work. Now, I can fix this by adding another if statement here, which is basically putting the give to in, well, basically, if I'm holding a data cube, then we do give to. Otherwise, we don't do anything. So, what we could do to speed this up is, instead of this, if we'll change out the way that I do this check here. So if my item is equal to a data cube, then we will have another internal if statement where we check if below us is a shredder, then we give to. Otherwise, we give to below. Otherwise, in the else of this if statement, we give to our right. So now it's going to run a lot more efficiently, because these people aren't going to sit around talking to themselves just because they don't have any data, they're not holding on to any data cubes. So now this program should run like twice as fast as the old one. However, it's like 2 statements longer than the old one, so I'm probably going to win the speed challenge here, but not actually get the shortest code challenge. But let's just go ahead and run through this. As we can tell, this is obviously going to work just fine. So just chuck all that shit in there. Okay, budget brigade, use 7 or fewer commands. I did 8. I also was too slow. So that's very interesting. If I look back at this... Workers can give to, no walking allowed, so we don't do any swapping of positions with each other. I guess probably... I'm trying to think if there's a way to speed this up, and the only thing I can think of is if it were possible to, maybe if I get rid of the else branch, that will work? What happens if I do that? That's now... I completed the size challenge because I got rid of an else thing, but everything runs a little bit slower because I have people just talking to each other over and over again. Well, that's fine. I got at least one challenge, so I'm happy with that. Let's continue to the elevator and pop up to Budget Brigade 2. Huh. It looks like going into the blue levels will have memory. Communication. What is this? Wow, this game is so much longer than the first one. Okay. But yeah, it looks like the blue levels have RAM involved, so that's going to be a lot of fun. Let's put that off for a little bit and do Budget Brigade 2 instead. I have a headache. No one is allowed to walk. Just be a conveyor belt, you know the drill. I also took the liberty of removing tempting floor tiles. Just read your instructions over there and leave me alone. Shred cubes of value 50 and higher on the right, smaller on the left. Shred at least 20 cubes. No one is allowed to walk. So, we want to do a check if below us is equal to a printer, then take from. And if, let's see, if we have a worker above us, or, well, okay, we don't need that. So if we have a worker above us, I need to fill this out and then delete it. If we have a worker above us, then we do give to. And I guess I can... No, I need to do that with that give to. So I was thinking of potentially just chaining up a bunch of give tos, but then these people won't really... I won't work for them, because they'll I can give this person 4 give tos, but I can't give this person 3 specifically, this person 2, or whatever. Like, it's not going to work out that well. So, if... Okay, else we don't have a worker above us. If my item is less than, let's say, 50. I forgot I can just hold this down, I think. If my item is less than 50... then we will just give to the left, and this is only contained if we don't have a worker above us, so that'll be just fine. My item is less than 50. Okay, so first off, if below me is a shredder, then and my item is equal to a data cube, then we give to the shredder. Otherwise, and then this branch corresponds to this person, funnily enough, because below them will never be a shredder, so then this code will never get executed. It's very interesting. I'm running the same code across every single, worker, but I have specific branches that only specific workers will execute, which is very, very interesting to me. Anyway, if my item is less than 50, then I give to the left. Else, we give to the right. And then we will just loop back to the start of the program. This should work just fine. Let's see what happens. So, we have... I see. So we also need to only do passing around if my item is equal to a data cube. And we need another check here if my item is less than 50 and my item is equal to a data cube. That way we don't have a bunch of people just sitting around talking to themselves. Now let's run this. Huh. Why won't... What are they doing? Oh, I see. There's another way to speed this up. So... De Morgan's Law. So I need to... I need to... I can get rid of this else statement. Because I should execute these sorts of code, or these conditions, only if my item is equal to a data cube. So we can just drop this down here. So we'll get rid of this statement, and we'll change this to if my item is equal to a data cube, Then, in this branch, down here, so you have to have a data cube to look at any of this code. If below me is equal to a shredder, then we'll give to below us. We don't need the else here. If my item is less than 50, then we will give to our left, else, and it needs to be the else of this check, else we give to our right. Now we won't have people sitting around talking to themselves. Perfect. Let's now check that this person does what they need to do correctly. And I'm holding something already. Okay, so 69 is going the wrong direction. So I screwed something up there. Ah, because I forgot to actually... What happened to this code? I remember clicking on this stuff. Did I click on it again? That's really weird. I remember counting this up to 50, but then my eyes must have slid off of it and I must have done something weird. So let's try this again. And the other thing I can do is, if below me is a printer and I'm not holding a data cube, then we'll pick it up. And that way, this person doesn't waste any cycles by talking to themselves saying, I'm already holding something. They will only take from the printer if their hands are empty. And this person... Why are these people doing checks to their left and their right? They shouldn't be doing checks to their left and their right. Oh, it depends on what cycle they're in. So, if I move this whole thing into an else statement, then these guys won't do left and right checks, which should speed up this code a little bit. But I don't know if that's entirely necessary, so let's see what happens if I just speed this up, if I win any challenges. Well, I haven't failed yet, so things should be going alright. I don't think I succeeded at the size challenge, and I definitely did not succeed at the speed challenge. Well, I beat the level, and you know what? That's good enough for my intents and purposes. Cool, so I think that about wraps up 7 Billion Humans for this one. But we will get back into this tomorrow, so thank you for watching. Welcome back! We have RAM. I am scared. My first shredding memory. Who doesn't forget the first time they shredded something? Certainly I won't, because I'm about to get RAM involved. Yes, gather around. Remember when we shredded our first data cube together? Of course you don't. You haven't had accessible memory. Until now! Yes, each of you can now remember 4 things. Got that? 4. You might store the location of a shredder you particularly like, or a special data cube you've got your eye on. Yes, I'm sure your memories will be very special and important to you. Watch what happens when you run the example program I took the liberty of creating for you. So memory 1 is equal to nearest data cube. So everyone's just going to go pick up the nearest data cube. And nearest is something that must be memory related. That's interesting. And then it gives me a label that I can either pick up that from a direction now, or I can pick up a memory slot. Can I give to a memory slot? I can. Alright. So this isn't going to probably be as hard as I thought it was going to be, but it seems like a really fun mechanic, so I'm looking forward to this. So what's going to happen is everybody's just going to run and they're going to pick up the nearest data cube. Pathfinding. Perfect. This isn't quite what I was looking for. Read the instructions carefully and try again. Okay. Got a new command. Nearest, it finds the nearest thing of a particular type and stores in one of your 4 convenient memory slots. You can access it later or walk to it later. So, nearest shredder, give to, and assign this to memory 1. Yeah, we can just use reuse memory 1, I think, and then we just do that over and over again. What's interesting is that by using nearest, I don't have to actually command these people to... I don't have to give them specific walking commands, so it's going to be a lot more... It's going to be a lot less code to accomplish a lot more utility. That's going to be really cool, because I assume that at this point in the game, it's going to get harder, but also the problems are going to get more abstract, and I'll be given more powerful statements than I had previous access to. So I'll be able to accomplish more with less code, because I'm going to be using these nearest things to control my movement around the level, rather than actually giving explicit movement commands. Alright, now let's just speed this up. Everyone will slowly run around and just destroy everything. And let's see how well I did. Well, I did the size challenge just fine. And I actually did alright on the speed challenge. Not amazing, but pretty good. I guess that another thing I can do to... I don't need to always check for the nearest shredder. I can just find the nearest shredder at the beginning, and I can just keep doing that. And that way, I am not constantly reassigning nearest to that memory slot, so people should be able to move through the code a lot faster. So I still complete the size challenge, and I still don't come in on the speed challenge, which is a little bit annoying. I feel like I don't really know what I could be doing better. I guess, yeah, this is very interesting to me. I wonder what happens if I just put this out of the loop as well. Okay, obviously that wasn't the best move. Okay, let's go back to the elevator though, because I don't need to really spend too much time optimizing this fitness program. Cinematic. No talking aloud from Bird.
You might be wondering, how does she stay so fresh and flirty?
Or hey, that handsome guy in the tie, is he a pneumatic excavator? Because he's pumped.
Let's all take a break from flexing our brains and work on flexing our bodies.
Today we're going to learn aerobic exercise with Alice, Betty, and Carol.
And Pablo. Hey.
Holy crap. I hope you all were doing what I was doing throughout that cinematic, which is dancing along. I mean, if you're watching a stream, you're watching YouTube videos, you gotta stay in shape, right? And you gotta take some time to, you know, move about. And if robots can get in shape, then why can't people? Then why can't people? Neural pathways! That cutscene was pretty damn epic. Hey, I remember this. This is like the trailer of the game. Was having a whole bunch of people do this one. Yes, let's all take a moment to reflect. Do you feel that tingling? Yes, that's a feeling of memories forming in your little heads. So let's just make sure we really blaze a path through our little neurons. Come get these data cubes over here. There's exactly one for each of you. How nice. And shred them. What? How can you find your way through this complicated maze? Don't worry. Your workers will figure it out on their own. Just watch and see. Okay, shred all data cubes. The solution here is identical to the solution in the previous room. Try it. Notice how your workers will automatically find their way to something they've stored in memory, even through a complicated maze. This is the future! Okay, so nearest, Mem1 will be Shredder. Nearest mem2 will be data cube. We will pick up mem1 and we will give to mem2, and there's one for every single worker, so I don't even need loops. We'll pick up mem2 and give to mem1. And now if I run this, everyone should be able to just loop through like that. Wow. Completed size challenge, and it looks like I exactly matched the speed challenge, so that's nice. I get two little green arrows, dots there. Biometric access. Yes, congratulations. You have each been assigned your own personal shredder. You will find it directly below you. I know they all look the same, but please remember very carefully which one is yours. Your new nearest command should help with that. Using someone else's shredder would be impolite, and also fatal. With that helpful information in mind, please enjoy shredding all the data cubes. I don't see how this is going to be any different at all from the previous one, so mem1 is equal to shredder. And then, okay, so we will... I mean, as long as we never overwrite mem1, then we'll never have a problem of people... I guess the trick is, if you put this mem1 in the loop, then you would fail. Because you would overwrite your mem1 with potentially somebody else's shredder, and then you'd die. So we're not going to do that. Instead, we're going to be smart, which is nearest mem2 is equal to data cube, and then we just give to mem1. And then we'll just keep looping through that. I forgot. Pick up mem2. Now people are just going to immediately chuck themselves into their shredders, which, I mean, there's something very poetic about having your personal shredder and then throwing yourself into it like you're some sort of Amikara fault character. But, that's not what we're going to be dealing with here. So let's just go ahead and just speed this up, because as we can tell, everyone's shredding just fine and no one's dying. Biometric access, speed challenge, and size challenge done in the first try. Continue to elevator. Fill the floor. I got an email. Let's see, just go to print it out here so I can read it. Sending it to that printer over there. Workers, I need you. Please fill the floor with pages from that printer. Don't worry, I'm sure if you work hard and press the right people, you'll get an email one day too. Fill the floor with data cubes. Tip for management, you can now select multiple directions inside your step command. Your worker will randomly select one of them to step towards. So, I wonder if I can do nearest... I can't do nearest empty tile. Well, if I have people just... If I have them go in every single direction and just move randomly, then they'll eventually touch every single tile on the floor. So what we can do is nearest printer is equal to mem1, and if my item is equal to a data cube, so first off we need to take from mem1, and we will have a jump statement at some point that takes us back through here. So if my item... How about if my item is not equal to a data cube, then we take from mem1. Else, what we need to do is we need to step in a random direction, and then if below me is a nothing, then we drop the data cube on the ground. And yeah, so this branch is, if I don't have a data cube, I go get one. Otherwise, I take a random step, and then I will... Well, here's what I can do. But we'll do the check first. That might be a little bit more efficient. So if we're holding, we'll put this in else. So I guess we don't need that. So we can have people just take, well, this way, if I put this in else, then the program is one extra line length, but having this extra random step isn't going to really make a difference on any particular worker's productivity there. So this should work just fine. And eventually they're going to just walk around and put everything on the ground. This is interesting to me because this is basically a Monte Carlo simulation, and if you don't know what that means, then study more computer science, noobs. And yeah, people are going to be mostly biased towards moving into this area and not really going down into this branch because this branch is so much smaller. So it's going to take a lot longer. Yeah, I was going to say it's going to take a lot longer than the speed challenge because I'm going to be very inefficient. What I can do is I can kind of bias to walk in certain directions, but I'm not really too interested in doing that for right now. So let's just continue to the elevator. Checkerboard organization. No more sloppy printing. Yes, I enjoy sophisticated data patterns. I'm going to print out an important document here. Would you please take its pages from the printer and fill the floor with a checkerboard pattern? That should leave some nice tiles unoccupied for browsing my document. I'm not going to step on my data like an animal. There's also death tiles everywhere. Okay. Fill the board with a checkerboard pattern. It's already been started for you. So basically I need to put things only on the light tiles. And that's kind of interesting to me. Because some of these workers are on dark tiles. And if it were possible, I could just have people only move diagonally. But I can't do that. I can't do that. So... This is very interesting to me. If... If it were possible, what I would like to do is get everybody onto a diagonal, which I can do, because you have to be on a dark tile to pick up from the printer. So we'll assign the printer to 1. Now, what I can do is every time I pick something up from the printer, I can just take a step up, or and that way, well, I can take a step either up or down, or I can always just take a step, well... Yeah, no matter which... Okay, so there... If I have everyone take a step to the right by default, then the person on this side of the printer gets screwed. So, I guess that there is going to have to be a check there to see which direction you are relative to the printer, and take a different step accordingly. That's kind of annoying because I know that that's a little bit inefficient, but this at least will help me solve the puzzle. So, if I am not holding a data cube, then we want to take from mem1, and if to my top is equal to a printer, then we will step down. Otherwise, we'll take a step up. So if we run this, everyone's gonna basically just be standing on some of these light tiles. And I hope that it isn't the case that they get screwed if something's blocking their way. Like if another worker is on this tile and they try to step up, they just end up not stepping up at all. I'm not looking forward to that being a potential thing that I run into, but I don't think it's going to happen. And I have nothing to actually prove that it's not going to happen except for blind optimism. So now we're in the branch of we are holding a data cube. And basically what we're going to do is if below me is a nothing, then we drop. Otherwise, we take a step. Otherwise, if to my upper left. Okay, this is super interesting to me. Oh, the holes are only on dark tiles, and none of my characters are ever going to step on dark tiles if I set this up correctly. So, as long as my logic here of getting everyone on light tiles holds, then they should be able to step on only light tile diagonals. Let's drop this to 1/2 speed and see if that happens. So they pick it up, they go up, and then they put it down. They take a random step, they exchange, this person goes up. And until I get people... Yeah, this is working. Everyone's biasing themselves towards these little diagonals. So until I get more people away from the printer, they're going to kind of bunch up on the top here. Which means that I don't actually need to... It looks like you have to always take items from the top of the printer, which I did not know. So then I don't actually need this check here. We can get rid of this if statement. And just have people always take a step up. Alright, now we should be able to just run this, and I'll run it at 12 times speed. We should see everybody just carefully dodging pits and putting everything into a checkerboard pattern. Again, my equally biased walking is problematic because it puts everyone in the upper right corner. But I didn't actually do that terrible. I am one command off and my average is 100. So I suppose what I'm potentially... I'm trying to see if there's a way for me to shave off one statement here. I don't actually see how I can make my program any shorter than it already is. Well, I don't care too much because I solved the puzzle. And that feels good. Yeah, my average is going to be about 110 instead of the 100 target. That's fine. Let's go back to the elevator, and we'll call this one here for tonight. So thanks for watching. Portal 2 looks odd. I have updated on Twitch like 7 times saying that I'm playing 7 Billion Humans. I don't know why Twitch does this thing. And YouTube actually does the same thing, and I hate it. I wish I knew how to avoid that bug from happening, but I haven't been able to figure it out yet, so not happening anytime soon. Just gonna chug a bunch of water, and then refill water, and then I'll be right back and we'll get on with creative writhing. Oh no. It's fine. I forgot Bert is a programmer, so he'll be good at this, lol. Excuse me. I'm pretty damn good at this. Not only am I a programmer, I'm a pretty damn good programmer, if I do say so myself. And I do say so myself. Got a lot of game ahead of myself here. I'm wondering when it gets difficult, because honestly, that came out as very smug, but honestly this hasn't been too difficult of a game so far. Actually, I wasn't recording. I'll keep my smugness off. Welcome back to a really, really easy game. The best way to start off an episode is to jokingly, allude to something I said between recording sessions. Anyway, yeah, so what I was saying to myself earlier was, I wonder when this game gets hard. And then I realized that makes me sound really, really smug. But I am really smug. So let's go to creative writhing. Adjectives. Nouns. Prepositions, articles, and Oxford commas. All critical components of clear, unambiguous writing. I'm trying to... They didn't use an Oxford comma because they didn't list 3 things. That's sad. Please enjoy your new command, write. It allows workers to change the number on any data cube they're holding. Yes, you can now write anything in the entire universe you can possibly imagine, as long as it's a whole number between 0 and 99. Make all data cubes say 99. So, what we will do is... I can use the nearest command and be really lazy and get a nice, like, easy program. So that's what I'm going to do. And what we're going to do is write on mem1. Huh. What? Oh. What? Huh? I can assign a number or mem1? That's really weird. Do I need to pick something up? Oh, yeah, I have to pick it up. And then we can do the write. I can't just write something on the ground. So what we'll do is we'll pick up mem1 and then write 99 on it. And this should be probably the shortest, easiest version of this code I can do. Now, this probably isn't the most efficient, because what's going to happen is people are going to kind of like walk around and walk all over each other and bumble their way through the puzzle. It's probably more efficient to have everyone go down their designated little path here. But... I forgot to have the drop command as well. So, go to the nearest data cube isn't really going to work because the nearest data cube is the one they're standing on. So watch this. We're going to pick it up, we're going to write it, we're going to drop it, then we're going to pick it up, write it, and then we're going to drop it. So I need to then do a step down. This isn't going to work because... Well, I mean, yeah, so if I do a step down, then the thing that's not going to work is that we'll never do that one. So, what it needs to be... I'm trying to think of the way to do this with the shortest amount of code. And basically we need to find the nearest cube that hasn't been written yet. So, if it were possible, I would have everyone take a step up and then put it down. But that's kind of not really that doable. That's not very feasible. So, what I have to do instead is when I do the drop, we need to not do this nearest thing, unfortunately. So, everyone takes a step down. And then they pick up their cube. And then if to our left is a data cube, then step left, and we wanted to pick up on that tile and just do that in the loop. If to our right is we can put this in the else, I guess. Yeah, this is going to be not very efficient. This is not going to be the efficient approach at all. So if my item... Okay. So if to our left is a data cube, then we step to the left, and then we do our pick up, right, drop. If, else if to the right is a data cube, then we step to the right. Else if, it must be the case that we have to take a step down because no data cubes above us will ever be, ones we need to write. So, else we just take the step down, and we do our pick up right drop. Let's watch this in slow motion. Not the prettiest code. I don't like the fact that I have this embedded if-else thing going on here. But this should work just fine, and I assume I'm not going to be winning either the size challenge or the speed challenge. So, and my right is not equal to 99. Maybe if left is not equal to 9. I don't know if I can do this check of 99. This will be very interesting to me. So what we're looking for is if this person steps to the right. They did take the step to the right, and that's because of this 99 thing. Let's try this again. And this feels like it might work. If this is not equal to 99. I don't know why we can... So I know that we can check against my item, but I think that this check against just a raw whole number won't work because I don't think they're going to read the data cube value. Actually, they just did read the data cube value. So this... Yeah, okay, this is kind of a cool little trick that I didn't know. So if I compare just against whole numbers, I will actually look for the values in the data cubes, and I can make certain behaviors happen as a result of that. We can just run through the rest of the level here, and... Yeah, I did not beat size. I did not beat speed. I didn't actually do terrible on speed. 42 seconds to 39 seconds, so... I wasn't too far off the optimal solution, but I was fairly far off the optimal size. Still, I'm just going to move on, and we'll do data backup day. In just a moment, everyone. I'm just finishing up an important report I've been working on for over a year. Type, type, type. Type, type. Yes! And done. Excellent work if I say so myself. Let me just save my work here, and file, save as... No. No, no, no. Disk abort fail. What? Stop. Retry. Gah! Who would have thought my entire career would come crumbling down due to catastrophic data loss? Haha. Don't worry, everyone. Did I fool you? Yes, I always knew I could have become an actor if this management job hadn't worked out. Clever. Data loss is something that can happen to anyone. It's nothing to be ashamed of. This is why we make backups. Let's all practice making backups over here. Each worker is a cube on both sides. The bigger number is corrupt. Overwrite this bigger number with the value of the smaller number and place them both back on the floor where they started. Get a new command, set. Set works similar to nearest, but you can use it to remember things on specific tiles, numbers, and many other things. Use the question button over there to learn more. You can use it to remember things on specific tiles. Interesting. Oh. So this is how I'll remember which tile I picked up the larger cube from? But that doesn't really make... do I even need set? I don't think I need set. Basically, I just check if... What are the nearest things I have? Okay, I don't really want to... I don't want to use nearest at all in this level. So if to the left is less than the right, I wonder if that works. So if left is less than right, then we pick up from the left. Else we pick up from the right. Maybe this works. That seems kind of classy. I don't know if that is programmed into the game to work this way or not, but we'll give it a shot. So what we'll do is we'll remember No, we don't need to remember anything. Oh, hang on. So mem1 is equal to set nothing. So is this going to set that location as the nearest nothing? I don't know. This might work. So what we do is overwrite the bigger number with the value of the smaller number and place them both back on the floor where they started. So if less is... So if, what we need to do is switch these pickup statements around. So if left is less than right, then we pick up right, because that's the bigger one. Else we pick up left. And our... I guess mem1 should be equal to right, because that's the empty tile. And then, otherwise, mem1 needs to be equal to left. That's the empty tile. We write from... I guess... mem2 would be the value on the left. I guess I do need set for this. And then mem2 would be the value on the right in this case. So it's whatever value is the smaller one. And then we write mem2. And then drop on... And then I guess we would want to... How do we walk to mem1? Oh, there we are. So we step to mem1, drop, and then mem3 will be just the starting tile. So mem3 is equal to the starting tile. And so we step to mem1, drop, then we step back to mem3, which restarts us because that'll put us in the middle here. So mem1 is going to be equal to the position where the data cube we picked up used to be. Mem2 is the value opposite of it. So we write the value opposite, we step to where the data cube used to be, we drop it. It's really weird that drop you can only do on the tile that you're on. But this should work just fine. So let's make this nice and slow and we'll just watch like this guy. So he picks up 95. He writes 30. I can't step to nothing. Huh. So... Huh. So mem1 didn't work. We did the right, but nobody actually made the step to mem1. So when we did this, I thought that would pick that tile, but what it's doing is it's trying to set the value on that tile to mem1. Okay. And if I do nearest nothing, it's always going to be the tile that we're standing on. So that sucks. But what we can do instead of having mem1 be that used for that, what we can do is just say if to our left is a nothing, we step to the left, and we do our... else we step to the right, and we do our drop, and then we step back to mem3. That's really weird that set didn't work the way I thought it would. So we've done our steps, and then, yeah, everyone says you can't step to nothing. Oh, I only needed to do it once, there's not even a loop required. Oh yeah, something puts the mind at ease, like redundant data storage. Haha. Yeah, you're telling me. Well, I got the optional speed challenge right. my size challenge was way too much. So we can get rid of this memory set here. We can get rid of jump. And I guess we don't... Wow. Do we even need Mem 2? Wonder if it's possible to do the nearest nothing. No, not. Unfortunately, I cannot do that. It'd be interesting if I could do step away from something, but I don't seem to have that ability. So I can get down to 12, a program of length 12, which ain't close to 8, but that's fine. I wonder if it's more efficient for me to just say set mem2 is equal to... I can set mem2 equal to itself. That's really weird. Tiles with nothing are like pointers to null, so they aren't really a direction to go. Ah, interesting. I never thought of that. I could have it be the case that if... So we set mem1 is equal to left, and then mem2 is equal to right, and if mem1 is less than mem2, then we pick up right, otherwise we pick up left. This didn't make it any shorter. We then write... Well, I don't care. Back. And that about wraps us up for today. So thank you all for watching. Okay. Just gonna get some water real quick. Welcome back to Seek and Destroy. Number 1, anyway. So I assume it's gonna be I need to find the nearest thing that I want to shred. Yes, I know what you're thinking. It's true. Every piece of data is a precious miracle. Workers each have a line of precious miracles above you. Yes, take a moment to appreciate them. They're all so green and uniquely numbered. Each of you must find the littlest data cube in your line. Aw, isn't that cute? But the problem with data is that small numbers just take up just as much space as big numbers. And storage space isn't cheap, you know. You can see where we're going with this. So let's just take that littlest number and shred it. Okay. Well... what I can do is just have people walk up in a straight line until they, I guess if they reach a wall, then they could just walk down and then shred it, which is probably the easiest, stupidest solution I can do, and it's exactly what I'm going to do. So, if my item is not equal to a data cube. Okay, the first thing we're gonna do is we're gonna step up twice. And then we'll pick up the item. So we've stepped up twice, we then pick up one above us. So yeah, this is interesting. I mean, there's something that I do at the start of a lot of my puzzles, which is I establish a precondition. So usually my precondition is get the workers to hold an item. Once that's true, then it's really easy to set up a loop because I don't need to loop back to like... I just know that if I loop back to this point, then I know it must be the case that my workers are holding an item. So I establish this invariant throughout the entire loop by doing that. So... that makes it really, really easy to reason about these puzzles. That's something I learned in my very first programming class. So it's a very common and very, very, never mind. It's a very, very common and easy thing to do to make your code a lot easier to understand. So anyway, step up twice, pick up that cube, and if... we'll just basically just keep taking steps up in a loop. And if my item is greater than the ground, then we'll pick up, or what we'll do is we'll drop to our right. Oh, we can't do that exactly. So what we'll do is we'll take a step to the right. Yeah, a step to the left works just as well. Drop the item. I wonder if I can just give to the left. But for now, we'll just take a step to the left, drop, and then take a step to the right to get back in line. And if there's nothing to compare against, I assume that we'd be comparing against null, which I assume will be 0. And that could potentially be very interesting. I'll see what happens in this case. My item, when we compare it against just the ground. So what we could do is, we're standing on a data cube, just to make sure that we don't compare against the ground unnecessarily. And if to the top is a wall, then we're gonna jump out of this loop. And we're gonna walk the other direction, which is... Oh, we don't even need that. We can just use nearest. So nearest shredder, and then we're just gonna give to the nearest shredder. This ought to work. Let's see what happens. You think in recursion, so the first thing you try to find is the base. That's exactly what I'm doing as well. I'm just setting up my base cases, like, effectively pick up the first item in the list, assume that it's the smallest one, and if it's not the smallest one, then we do this sort of logic. But interestingly enough, this person did not pick up the data cube because I forgot a certain step, which was we step back in and then we pick up our data cube again. We pick up the newfound smallest data cube. But yeah, so the easiest way to find the smallest item, or the most correct way to find the smallest item in a list of items, is you always assume that the first item is the smallest one you've seen, and then you go through the rest. And that's exactly what I'm doing here, and that's a popular job interview kind of gotcha for, like, effectively filtering out people on phone screens. So don't say you didn't learn something. And I think that that ought to take us through this puzzle here. They picked up 4, they picked up 14, they shredded 31, they shredded 12. Perfect. I don't think I did either of the optional size, but I think I must have done well on the speed. Ah, I'm so close on the speed. I guess the dropping commands probably were what killed me there. I wonder if instead of these 3 commands, I can do nearest data cube at mem2 and just pick up mem2. So this will run faster because I'm only running 1 command in a given cycle. So this should mean... Oh, the other thing is I have people going up to the top wall, which is not actually necessary. Yeah, I have everyone bouncing off the top of the arena, which is probably what's cost me those last couple of seconds there more than anything else. Oh, well. Your all-time fastest solution averaged 23 seconds. So I beat my all-time. I wonder, what's the trick for making sure that I don't have to bounce off this top wall here? If there was furthest, that would be hilarious. But I only have nearest. So I wonder if it would be possible to set... it'd be really funny if I could set that tile as the... So this just sets it to 1. It'd be interesting if I could set a counter. So if I could set it to mem1. If I could do addition by, like, setting a counter, then I could just check, like, if I've checked 6 things. Oh, but some of them have different numbers of things anyway, so that wouldn't really work. I wonder if instead of doing this drop, step, drop thing, I can do give to the left. Yeah, I can't do give tos on things that aren't shredders. Oh, interestingly enough, I don't need to shred only the smallest data cube. I can shred every single cube. So... I can complete the speed challenge, the shortest code challenge really easily here. Watch this. So, Mem2's nearest data cube, and we'll just jump, and we'll pick up Mem2, and we'll give to Mem1, and I've now completed this in five steps. Ah, all your workers have died? Why didn't that work? Oh, I guess I guess they do have some sort of check to make sure that you actually shred the smallest one. I thought for a second that I had found a loophole, but that's fine. Technically, by doing that, I would have shredded the smallest data cube in every column, so I don't know why they're not letting me get away with that. They specified no statement that I need to only shred the smallest data cube. Yes, did you notice? Whenever we delete the smallest number, there's a new smallest number remaining. If we delete that number, well, you see the problem here. Clearly we need to shred all the data cubes, but not in any random order like we used to. Each of you must shred all data cubes in each of your columns in order from smallest first to biggest last. Copy and paste your solution from the previous room as a starting point. This will take no time, basically, because all I'm going to do is just put this thing effectively into a loop. Ah, crap. Ah, craps. Ah, crap and a half. Oh. Oh. Well, I guess we're going back to the Seek and Destroy 2 challenge. Okay. So. Yeah, we get it. Okay, so we'll do nearest data cube. I hope that... Alright. So what we'll do is we'll have a loop to start with where we step up, and if we're standing on a data cube, then we pick it up, and... we'll do a jump statement to get out of the stepping up loop. Okay, otherwise, we will just keep stepping up until we're standing on a data cube. Now, so this is just going to be called get cube. This one's going to be called get lil boy. And then we'll just follow the same sort of thing that we were doing before. Alright, so what we do is if... Okay, so what we do is just keep walking up, bounce off the wall just like we were doing beforehand. If above us is a wall, then we're going to jump out of this thing. Oh, no. So first we're going to set our shredder to be the mem1. So now we'll just give to mem1, and then we're going to jump back to get cube. Otherwise, what we'll do is we'll do a step up, and if we're standing on a data cube, or rather, if my item is greater than what we're standing on, then we will... I wonder if I can just pick up the item on the ground while I'm holding one and just swap items. I didn't actually try that. Let's give that a shot and see if it works. So what we'll do is we'll just keep We'll just keep doing that. And this should eventually get everybody to shred the smallest items in their list in order. Okay, yeah, if they're already holding something, then they don't do the swap. Okay, That's annoying. That's really, really annoying. I wonder... what I can do is... I can just go into another loop where I keep stepping down until I find an empty tile, drop the item, then go back up and pick up the smallest item. The other thing that I can do, actually, that's kind of clever, is I can just sort everything to begin with, and then have a loop where I just go through and pick up items until I shred them all. That would be really, really classy. That's actually a really classy solution. I like that a lot. But swapping stuff is only really easy if you have other workers to do it with you, because then they can actually swap positions physically. But we don't have that, unfortunately, so what we'll do is... sorry about that. We'll set my position as Mem1. Huh. I don't know what this is about, because I'm setting this... Okay. I can't tell if this is going to set that as a tile, or if it's going to set it as the value on the tile. I'm sure that it's going to set it as the value on the tile. Huh. What about nearest... it'd be cool if I could just do the, nearest empty tile. But I can't quite do that. And I can't just have people, like, do what they did beforehand, which is step to the left, drop the cube, and then step to the right, and then, this is confusing and hard. And then there's this row, which has more cubes than I have spaces to drop the cubes. So I can't just drop all my cubes in a line. What I am thinking could be kind of funny is if I just seek out every single cube in its smallest, like... No, I can't do that either. Like, just find every cube that's small, or the smallest globally, but that's not going to work. If you set a tile with a cube, it saves the tile and the number. You can compare it with ifs and also step towards it. Awesome. So I will set that as that tile. Okay, that's all I needed to know. Thank you for giving me that little tip there. So what we'll do is, if my item is greater than that spot, then what we'll do is we'll just step around randomly until we find an empty tile, put it down. But that's crazy. But it's also going to work. So what we'll do is, my item is greater than that, then we're going to enter another loop. So we'll pick it up, and we'll just step either up or down. And if I'm standing on a nothing, then we'll drop it, and we'll break out of this loop. Or no, we'll drop it. Oh, God, this is insanity. No, this will work. So we'll drop what we're holding. We will then step back to Mem 2. And then we'll jump back to this step. This is weird, but I like it quite a lot. Otherwise, we didn't find a nothing, so we just take another step in a random direction, and check if we're standing on a nothing. Alrighty, this is hilarious to me. This is gonna get real magical real quick when we have to do our first comparison. So they're already holding us something. So they step, they drop that. Okay. The other thing that they need to do is after they do their step to Mem 1 or Mem 2, then they pick up the cube. I had that in a slightly wrong order. So they pick up 2. 34. This is working. I'm looking at this person. They're currently stepping around randomly until they find an empty spot with which to put their tile down on. They found it, then they're going to walk back to 6 and pick up 6. They're going to walk all the way down with 2 and shred that. 28 is smaller than all of these numbers, so this worked with random stepping around. Hey, I solved it, didn't I? And watch, they're going to pick up 17, shred that, 36, shred that, 37, shred that. Hey, that's actually not terrible, I don't think, in terms of the speed challenge. It's bad for size, but I kind of nailed the solution. Kind of. And we'll do Seek and Destroy 3, and hopefully I won't delete my solution between the recordings next time, so thanks for watching. Thank you, Another Gaze, for your helpful little insights there about the memory setting thing. You give good hints, because you don't tell me anything that I don't really need to know. So thank you very much for giving, like, that's like the perfect hint to give, is you can sense when there's one very small piece of information that the game doesn't explain super well, and then I can just feed off of that to get the rest of the way. That's awesome. You don't tell me, like, oh, you need to do this thing to solve it, or anything like that. But, there you go. Let's move on to Seek and Destroy 3. Hey everybody, welcome back. Let's move to Seek and Destroy 3. Oh no. Sometimes, when we get excited about an engineering problem, we can lose perspective, and we forget what's actually important. Yes, your last assignment was engineered very cleverly, but we still deleted all our data. Yes, let's not worry about who told who to do what. The important thing is that we need to show a little restraint. Please delete 1. Only 1 data cube. It must be the smallest one in the room. Let's all work together to do as little as possible. Okay, so we have this person here. And what they're going to do is they're going to be our swapping point, I think. So what we can do is have everybody go to the top and then just conga line down to this guy, and if and they'll just do a comparison over and over again, and the way that'll work is if to our bottom is a worker and my item is greater than this is interesting to me. we're getting a little bit ahead of ourselves. For now, what we're gonna do is we're just gonna have everyone just walk. So what? Yeah. What we're gonna do is have everyone just walk up and get the smallest thing in their line, and we'll just have a loop where they can just keep going down and just drop the data cube when they need to do their swapping. So, without any further ado, let's just step up twice, or let's just do nearest data cube pickup from mem1. So that gets everyone to this tile. And then we do step up. Oh, hold on. If to our above, we don't need to do what I've been doing this whole time. We can, at least on this one, we know that, oh. Okay, never mind. I was going to be very clever, but what I was thinking was that if we're always standing on an empty tile, then we only need to check the tile above us and then put it down. But that's actually not true, because that's only true if it's already sorted for us in reverse order. So that's definitely not going to be the case. Alright, what we're going to do is, if we're standing on a data cube, or rather, if above us is a wall, then we're going to jump out of our everything. Otherwise, this is going to be part of our loop here. So this is set up, and this is going to be this is going to be get small boy. And what we're going to do is we're just going to keep stepping up. We make our comparison. Otherwise, we will then do a check of if my item is greater than what I'm standing on, then we have another loop where we step down until we find an empty. And we'll need to do a set of where we are. We do a step down until we find the nearest empty tile. If we're standing on a nothing, then we drop our data cube. We will step to where we left off on mem2, because mem1... Oh, we can actually just replace mem1 already. So we'll set that to that. And we don't need to save mem1 beyond the very beginning of our setup there. So, drop, step to mem1, and pick up from there. And we're just going to loop infinitely, doing this step down. Once we've done our pickup, we will then jump back to this point where we do our stepping up until we get to the wall. So I'm going to run this program, and if everyone ends here with the smallest tile in the row, then we can resume our logic from there. If below us is equal to a shredder, then we want to not move, which is very interesting to me. So we also need code for Shred Boy. Which is, if we're standing above a shredder, then we're just gonna, for now, we're just gonna keep looping that check over and over again. So this guy never leaves his post. He left his post. Right. Because he's doing this command to get the nearest data cube. So for now, we're gonna also put this at the very beginning of the program. It ain't great, but it works. And they need to do that. So they just sit there idling for now. What I'm focusing on is getting everybody through here with the smallest item in their list. And taking a quick stock, we have the smallest item in the list, and everyone's at the top here. So, we now have everyone at the wall. We're then going to conga line to the left until we hit a wall. If to the left is equal to a nothing, or is not equal to wall, then we step to the left. And we're just going to keep doing that until, let's see. So basically when we get to here, we want to then step down and start swapping with this person. But what do we do to make that happen? We'll just keep doing this loop over and over again. There's actually an easier way of doing this. So that's, if to our left is equal to a wall, then we jump out of it. No. This is what I need to do. There we go. So we take steps left until we're at the wall. If I run this, we should now have everyone over to their left. They're now doing a bunch of random swapping, but that's fine. The point is that we eventually got everyone to hang out by the wall. So now we will then take a loop where we just keep stepping down. So we step down until my item. So this guy, Shred Boy, is very interesting. We'll come back to them in a second. But what we want to do is we want to step down, and if to my if beneath me is a worker and my item is greater than theirs, then we'll do give to that guy. So I want it to be the case that he ends up holding the smallest item. Then when we've done our give to, we're gonna jump out of this and we're just gonna step to the right infinitely. So ideally what happens is everyone goes up, they talk to the wall, they come down here, they give their item to this guy in the smallest order. But if he's holding something, then that won't work. So this is super duper interesting to me. Give to won't work. We'll need to actually have the workers swap positions. That's going to be a little bit interesting to me. Let's see what happens. So they're going up there. 31 gives to that guy. Oh, no, they don't actually give to that guy. Huh. Why isn't this command ever being met? Let me see what happens again. So I'm now observing them. The person on the bottom here. I want to see what happens in this loop specifically, because they didn't do what I expected them to do. They never broke out of the loop. Oh, because I don't think that this condition of if my item is greater than nothing, it works. So, if my item is greater than them, or below me is not equal to a data cube, then we do the give to. Oh. So I needed to put these in parentheses, basically. Huh. Alright, and that still doesn't actually perform the swapping, it's just doing a give to. So, let's actually fix that now. If below me is not equal to a worker, then we just keep doing the step down. Otherwise, we are now facing this guy. We're now facing this worker. If my item is less than the item below me, then we want to step into their place. And then we want to jump to the Shred Boy code. Which is interesting. If we have a shredder beneath us, then what we're going to do is we're just going to keep looping through this code, which is if my item is greater than the one above me, then I want to step up. And if above me is a worker. So now we should see it. We should have these people swapping positions. I hope to God this works. Let's find out. Okay, so 23 is coming down. This is the critical moment here. Did Shred Boy work? Nope. Shred Boy doesn't have an item, so he's not picking up anything. So if my item is equal to that, and we have a worker, how about if I don't have a... If my item is not equal to a data cube, and... Okay, the condition is if above me there is a worker as Shred Boy, then if my item is greater than theirs, or if my item is not equal to a data cube, then we'll swap with them. So now the condition is if I don't have anything at all, then I just gotta get out of the line. Once I've done that, I'm no longer Shred Boy. So what I should do is I should be a get out the way boy, which is I come down here, all the way down here, and then this code is just step to the right a bunch in a loop. So once you become if you lose your Shred Boy status, you always step to the right. Let's see what happens. They're stepping to the left. These people fucked up. I will figure that out in the future. These people fucked up. Oh boy. 32 lines of code, and this is getting really, really complicated. Oh boy, oh boy, oh boy. What I can do is, as a hack, I can just step down infinitely until I'm not stepping on a shredder. If below me is equal to shredder is not equal to a shredder, then we just keep doing this. That's silly, but that way we actually are forced to do the swapping in the end. Let's see, 24 comes down. These two don't swap, so it's fucked up. Ah, come on. Okay. The other thing I can do is, if it were possible, I would have everyone just sort up here. Am I required to use Shred Boy? I don't think so. So, what I could do is I could have this guy It's possible to solve this without picking up any other cubes than the smallest one? Wow. Well, that's really interesting to me. I wonder if you can do that with memory. Which is just have everyone walk through. Oh, hold on. If I have everyone walk through, they can remember their biggest number. And then, what can I do about this? Is it possible for me to set it to somebody else's memory? I'm wondering if I can just have everyone step through their lines, picking up the smallest one that they've seen, which is, oh, okay, that actually makes sense. We just have everyone get step up twice, remember their current one, and then just keep stepping up and pick up the smallest one. You set one to a tile and then compare it to other tiles no need to pick up. Yep, I now see that. My code is nonsense. So what we're gonna do is we're just gonna reset the whole puzzle because everything about what I made is nonsense. So we're gonna step up twice. Or rather, we can just step up. And is it possible to set above me Mem1 as the smallest? So now we just step up until we're at a wall. And what we're going to keep on doing is if Mem1 is greater than what I'm stepping on, then Mem1 is equal to what I'm stepping on. Once we're at a wall, then we stop doing this. What we'll do is we'll do nearest, or rather, we'll pick up Mem1 because it remembers the value and the tile. Haha, that's cool. Okay, so these people are gonna do that, and I forgot to have a loop. Okay. So we've set that to be the smallest one. If I just look at this person, they're still remembering 2. They're remembering 2. They're remembering 1. They're remembering 7. This is working just as intended so far. So everyone makes it to that, and then they go pick up their smallest one. And then what I need to do is... So everyone's picked up their smallest one. But how do I make it So everyone picks up the smallest one in their row. So that's great. But I still have this problem with Shred Boy. My code is significantly faster and significantly quicker. So what I can do is have everyone drop it and have somebody go through and do the same thing where they loop through this code, or this row on the top, and check all of the tiles. Yeah, just check them all. And Shred Boy can have his own routine where he just kind of loops up through here. He'll take twice as long to walk through everything. Then we know for a fact, if he takes twice as long to walk through everything, then we know for a fact that in the worst case scenario, he'll be here at the exact same time everyone's come along and dropped all their stuff. So what we'll do is, if we're at a wall, then we'll set mem2 to be my current position. We go pick it up, and then we step back to mem2. We drop, and then we take a step down. So what's going to happen is everyone's going to leave their smallest tile in a row at the top. Meanwhile, this guy's going to just do whatever. They're going to leave their smallest tile at the row at a row at the top, and then I want them to end. Shit, why didn't that work? What did I change? What did I change that didn't work here? So everyone goes to pick up mem1, and they step to mem2. So they all went and they picked up their smallest thing, and then they can't step to nothing. Right, because they can't step to a tile without anything on it, because that's null. Crap. Okay, so what I can do instead is have everyone go through the step-up loop again. So go to pick up the mem1. We then will do up steps until we're at a wall. We do the drop, step down, end. Otherwise, we just keep doing step up. And I can make this code a little bit cleaner by just saying if we're not, like, just reversing it, but this is, like, really, really straightforward. Okay, so they kind of talked over what I was attempting to do there, so we didn't actually see it in action. But as you can see, everyone has now stepped down, and they're out of the way of Wallboy. Okay. So, now, what we'll do is, if we're in top of a shredder, then what we do is very different, which is we take a step to the right, a step up, and a step to the left. And we just keep doing that until we're at a wall above us. Once done, then we do a different routine entirely. So if above us is not equal to a wall, then we jump to here. So that'll get Shred Boy up to there, and that'll have cleared out the lane so he's able to just walk straight through everybody. See that in action. Perfect. That, yep, okay, so this didn't work out the way I thought it would at all. That's a shame. I thought that by doing this sort of snaky pattern, he would have to be slower than everybody else, but he wasn't. Because everyone else has such complicated directions that this is too fast. So what I can do is I can have this guy just waste a shit ton of time. So I can have him just do like a step to the right and a step to the left, and then a step to the right. And then a step to the left. And then a step to the right. And then a step up. And then a step to the left. Which is a really, really, really dumb idea. But this might mean that he's slow enough to stay out of the way. Okay, so as soon as we have a wall, then what we're doing as Shred Boy is we step to the right twice. And we do, so he goes there. We set that to be the tile that we're standing on. And we're going to do another routine of getting the smallest tile in a row. So, we'll just do a routine where we step to the right. And if we're standing on, if mem1 is greater than what we're standing on, then set mem1 to what we're standing on. And if what is this monstrosity of a game? This is multi-threaded programming, the video game. If we're on a nothing, then we will end for now. Well, okay, if we're on a nothing, then we pick up from mem1, and then we should also have nearest of mem4 is equal to the nearest shredder. And then we'll give to mem4. And last but not least, I need to have a jump so that we keep taking steps to the right. This is nonsense. Everyone's picked up their items, they've put them down, that guy's gone through, looked at everything. They picked up 7 and they shredded it. Holy shit! I didn't do that bad! That's nuts! That was nuts! Alright. Alright. Good God, that was nuts. Thank you for the tip, Another Gaze. You've kind of leveled up my playing styles once again by telling me that I can just compare against memory. Very clever. Very clever. This is an unholy monstrosity of a game. I have time for, like, one more level, I think. I'm gonna get some water, and we'll power through one for another 15 minutes or so. Oh. I bought Oreos. I bought Oreos, so I had to take a second to eat an Oreo because I don't think it's humanly possible to walk by an Oreo tray and not eat an Oreo out of it. Alright. Intro to Calc for art majors. As somebody who was both an art major and a mathematics major, well, it wasn't mathematics, it was computer science. I consider that mathematics. I'm terrified about what this is going to be, but I assume it's going to insult me either way. No matter what, I'm coming out of here getting insulted, possibly in both directions. Let's find out. What's 4 plus 2? What's 5 minus 3? What's 1 times 3? How is anyone supposed to know? We're not scientists. That's why you got a calculator. You can now use your new calc command. Use it to add or subtract or whatever else calculators do. Let's practice. Please add 1 to each of your data cubes below. And place them back on the floor again. Excuse me. Pick up. Pick up below. Calc. My item plus 1. Right. Mem 1. I guess I need to just drop it. Yeah, then drop. Everyone picks up their thing, remembers their item, writes it, drops it. Human resource machine. I mean, 7 billion humans. And I got the double light challenge. Perfect. Dangerous spreadsheeting. Did everyone have fun at the holiday party? Oh, you weren't invited? Well, I'm sure cleaning up after a party is just as fun as being at the party. Because someone got into this room and damaged a bunch of data. So the tech support people want us to take inventory. See that table of data over there? Just add up each row and write the total sum of each row in that column over on the right. I mean on the right. Oh, it was a rough night. Watch out for the hole. Holes. Holes. Oh no. Oh fuck. Oh no. What do I do about holes? Oh no. Ha 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 ha. Well, I guess if I encounter a hole, then I need to step down? But everyone's kind of staggered across their holes. Some people have 2 holes, and I'm scared. I'm scared about what this is entailing. How on earth do I deal with the holes? I don't understand. Well, I mean, the basics of this are pretty straightforward. Which is what we do is we always go to our nearest. Oh, we don't have nearest anymore. So it's basically just step to the right until we're on, or if we're until we're not on, while we're not on a data cube. Once we're on a data cube, we then do, well, we just do calc of whatever we're on, of mem1. So first we set mem1 to 0, which I think it's probably already set to 0 to begin with. But let's find out. So we set mem1 plus what we're standing on, and then we just step to the right over and over again. If to our right is not a wall. Once it is a wall, we then then we do pickup. We write mem1, and then we do a drop. So this is the solution that does not account for holes. This person will succeed, this person will succeed, everyone else will die. But, we'll just use this to double check. I don't know why. Oh. If to our right is not equal to a wall. Alright, so let's double check this real quick. 8, 16, 17, 25, 28, 10, 13, 16, 19, and 18. Yeah, okay. If it's 2 out of 3, it's fine. Okay, so the people that didn't have holes lived. The people who do have holes, I don't know what to do about them. If right is equal to hole, then die. Well, that's what they're doing. So, what I need them to do is just basically enter a routine where they just step up and walk around the hole. But I'm afraid of what will happen in case they end up walking into one of the workers. But I don't think that's actually an issue. I think that'll work just fine. So, if to our... Okay, so we take a step to the right. We do this mem1 calc thing. If to the right of us is not a hole, then we take a step to the right. Else, we step up, and we're just going to keep walking to the right until there's no hole beneath us. So, we'll take a step to the right. If below us is not a hole, then we will jump back to there. Once it is a hole, or... Okay, so we take a step right. If below us is a hole, then we take another step right. Otherwise, we take a step down. And then we continue the execution of our program from here, where we do the calculation memory plus whatever we're on. So, this should now account for holes successfully. I think that people just wait over and over again if they're blocked by another worker. And, yep, this looks just fine. Alright. That wasn't so bad. I did damn good on the speed challenge, too. So that's really nice. I think that the only thing that I could do a little bit differently is there might be... I'm taking a little bit too long because I'm doing an extra calculation of 0 here. So I don't need to actually do that if there's a wall to my right. So if to my right is... So yeah, the only thing that I'm doing a little bit wrong is this check against the wall thing. But yeah, because everyone's taking a moment to mentally calculate 0 at the very end. An addition of 0 doesn't actually matter. Blah, blah, blah. Let's just continue to the elevator. Printing etiquette 1. Yes, we need to have a conversation. Someone in this room, we won't say who, has been abusing their printing privileges. They are printing personal holiday cards, photos of themselves standing in front of the bathroom mirror, excerpts from some sort of fan fiction novella. They are clearly lonely. Yes, we need to learn to limit our printer usage, and not print like we're trapped in some sort of infinite loop as if data can be copied indefinitely. Yes, please work through our printer mindfulness assignment. I'll just leave the pamphlet's instructions over there. We need to increase our awareness of our printing. Each worker must print exactly 5 data cubes and place them anywhere on the floor. And really think about the impact of each one. Okay, mem1 is equal to nearest printer. So what we'll do is, we'll do 2 things. If my item is not equal to a data cube, then take from mem1. Alright. We now have an item. Okay, so now we say if my ground is equal to nothing, then I drop if mem2, which is, I do drop calc mem2 is equal to mem2 plus 1. If mem2 is equal to 5, end. Otherwise, we jump back to get another item. Couldn't be simpler. They picked up 37, and I forgot to have them take a random step. So, what we do is, if my ground is equal to nothing, then I do drop. Otherwise, I take a step in a random direction. And I do a jump back to check if I'm standing on a nothing. Alright. So they did 52. They've printed one thing. They now take a step in a random direction. They have an empty tile. They know not to check again. Everyone's just going to keep doing this. Perfect. Could not be simpler. I think I probably did alright on the speed challenge. Yeah, okay. I'll take it. And the size challenge is alright. Cool. Definitely pretty happy with how that went. Printing etiquette number 2. Remember how earlier I was asking about a counter? Well, I got my wish. Here we are again. Yes, it appears our polite printing pamphlet was out of date in the previous assignment, and we wasted 25 data cubes. Please enjoy your updated assignment. Go copy the solution from your previous assignment and paste it in here. Each worker must print exactly 5 data cubes, but this time each worker must label their cubes 1 through 5. Place them anywhere on the floor? Wait, so I then also do a write of mem2? That's easy enough. How is this hard? Blah, blah, blah. Copy. Back. Printing etiquette. Blah, blah, blah. Paste. So all I do now is, instead of doing my drop, before I do mem2, I do a write of mem2 onto the item, then I drop it. It's literally just one extra command. Huh. That... I don't get what was supposed to be the challenge of that one. I guess it was to teach you the basics of, like, maintaining a counter and writing it out, but I don't see how that's really that hard. I don't know. Multiplication table sounds terrifying. Image decryptor also sounds terrifying. Let's check it out. Happy birthday to me. How nice. I was sent a birthday image from my bank, but it's a secure image and they encrypted it, and I have to figure out how to view it. Yes, I'll just log in here to my secure online banking portal and verify my security questions and type in the security code they sent to my mobile device, and type in my previous 4 addresses and accept the updated terms and conditions, and agree to paperless communication and navigate the tutorial on how they recently slightly redesigned one of the buttons on the website, and decline a credit card offer and decline another one. Okay, here we go! Here's how to view your birthday image. An image of a lady here with a big hairdo says, "It's so easy." They say we have to move each cube. To the left, the number of tiles listed on each cube. Once that's complete, my personal birthday greeting will appear. Oh boy, I can't wait. Alright, easy enough. So everyone just picks up the cube that they're standing next to. And then they'll just set mem1 to my item. Oh no. We should have everyone step to the left and then pick up the cube that they're standing on. They set mem1 to what they're holding, and basically if mem1 is equal to 0, then we'll drop the cube. Otherwise, what we'll do is we'll just step to the left and calc mem1 is equal to mem1 minus 1. Let me just keep jumping through here. I moved the wrong thing. Couldn't be simpler, right? So the people that moved 1, they're at 0, and they did their drop, which makes no sense. Oh, maybe it does make sense. I think this is working. I wasn't actually paying attention to some of the bigger numbers. What's not working here? So I have this symbol, right? Oh, I see. This is important birthday message is private. All workers must then exit the room by stepping into one of the conveniently placed infinite pit holes. Alright, funny. So, if it's equal to 0, then we drop. And then we just keep doing step up infinitely. So now everyone will just, die. Well, isn't that nice? It looks just like me. Happy birthday to me. Wow. How did I do so bad on the speed challenge? How could I have done that bad on the speed challenge? Do I do nearest hole? And then step to nearest hole instead? Does that really speed things up? No. I don't understand how people can do this in half the time that I can. That's kind of interesting. I don't know how they could possibly... Oh. Instead of always checking mem1, they could just step to the left however many times they need to. Instead of doing this down by 1 every time. Right? I don't know. Point is, it's done. Multiplication table is a hard one, and I don't really have time at this point to do any more, I think. So that's probably where I'm going to leave things for tonight. But tomorrow, we'll take on the multiplication table, and I'm probably going to cry because I imagine it's going to be really, really difficult. I am hauling ass through this game, though. I think this is my second play session of this, and I'm on level 42. Damn. I'm good. Have a good night. And that is it for the stream tonight. I hope you all enjoyed this approximation of a game. Insofar as, yeah, it's a game, but also it's work. Boy, is it work. This is a hard game. But I had fun anyway. So, tell you what, I will catch you all tomorrow for... Oh, no, tomorrow's my night off. So I probably won't stream tomorrow. Unless I do, we'll find out. Anyway, good night.